Hey everyone, welcome to our new video. In this video, we are reviewing test 3 problem, and I'm your host Ujwal Gupta. So, our problem is pretty cool, which is we have to prove x mod ny mod y is equal to x mod y for all integers n. So, n should be an integer, and its process is not very hard, and I'm sure you guys gonna get it. So our first step would be to just say like x mod y is equals to p. Just assume it, so that like things get a little easy. And where you know uh, positive value of p is less than positive value of y. Basically the digits are less, okay. And p is an integer. According to the definition of mod, there exists an integer m such that x is equals to my plus p. So what we basically did is we tweaked our problem a little bit and made mod x mod y is equals to p, and we put it there in the equation. If I go back to show you guys, so this is something we have to prove, and we are heading from here. This is basically a mod y, right? um, and this is our equation 1, and we go further and we say okay, x mod ny is equal to a q, where the same thing, where q is less than ny, and they both are absolute values, and q is an integer. The same thing, nothing very different. And we also know one more thing about mod, that whenever there is a mod, we get a t there, and so it's just a different form of writing it. So here we wrote it as x is equals to t braces ny plus q, which would be our equation 2. So now we have equation 1 and equation 2, and our next step is cool. Yeah, I mean, things are getting they are on the right place right now. And now we try to prove the equation, okay. So we have an equation 1 and equation 2, and we have to prove this part: x mod ny mod y is equals to x mod y for all integer n. We know that, right? And our equation 1 is this. And what is the value of x mod ny mod y? This is what we have to find. So let's go further. We used our equation 1 and equation 2, and tried to mix a little bit. So we first moved our equation 1 and equation 2 a little bit, and make it like q is equals to x minus nty. And then what we did was, we know the value of x from the first equation, so we put that on the equation 2. We tweaked, and now we have my plus p minus tny is equal to q, and we did a little bit of math here and we got this, okay. So now we have q is equals to m, this stuff, okay. And thus we get q is equals to m minus nt y plus q, plus p, my bad, which is basically an integer, m minus nt is an integer. And our since we were using the same situation, so yeah, p is also absolute value, p is also less than y. And we then move further, and now we know like q mod y is equals to p, okay. Since m minus nt is nothing but just a number, we can say mod y, right? So now we assume something. Since we know q mod y is equals to p, now we can assume something like x mod ny is equal to q. I think you're getting this part, and we just assumed it. And just hold with me for the next part. And now we say that x mod ny mod y, we just multiplied a mod y, you see, and is equals to q mod y, which technically is p on the fourth line. So that proves our point, right? And so yeah, our mission is achieved now. According to our assumption, we have proved that x mod ny mod y is equal to p when p is equals to x mod y. That's what we assumed and we proved it. So yay. And yeah, one more thing, and n is only integer, n is nothing else. So thank you so much for watching and holding with me for so long. Have a great day ahead.